Okay, Akshita, so let's start with that. So diffraction of light with a single slit diagrams I had shown you, right?
Yeah.
Okay, so interference of light, now we have to start. Done. So let's start with that. In C3, a very small topic is remaining, and that is interference of light. Done. So what do we understand by interference of light is, like if suppose two light are interfering each other, which are coming from a same source, and they both are coherent in nature. Okay.
Yes, ma'am.
And let me draw the diagram for you first. Suppose I have a slit over here, and here I have the source. So the pattern has been created. Okay. Now, if I give it a two slit pattern, then here one pattern will be formed like this. And here one pattern will be formed like this. Okay. So the central line where they are meeting up all the light rays will give you central bright fringe, which will be constructive in nature.
Yes, ma'am.
Okay. Whereas the second where they are meeting up will be first bright fringe. Okay. In between of this, you will get the dark fringe. Okay. Similarly here, where they are meeting up at the second point will be your first bright fringe in the left hand extreme, and this will be your dark fringe in between. Done? Okay.
Yes.
So somewhere like this, you will get the pattern, and this particular experiment, which has been shown over here, is known as two slit experiment. Okay.
Yes, ma'am.
Done. So here what is happening? The light are interfering each other. Done. Now the conditions for this to get happen is the source should be coherent in nature. Okay. That means what? They should have the same frequency, amplitude, constant phase difference. Okay. And after that, this can be achieved basically but just by using only one source and one slit. And after that, passing it into two slits. Okay. Now, for this particular thing which is happening over here, we have some mathematical concepts also. Okay. Let's focus on to that.
Yes, ma'am.
Have a look at this diagram. Okay. Since here, this is the first interference, okay, which is happening. Okay. As you can see over here, that the first interference which is happening, okay, over This point I am talking about right now. Okay. So at this point, the interference is happening and this is giving a central maxima. So you need to consider that central bright fringe is also known as central maxima. Done. Then the first bright fringe is also known as first maxima. Then first dark fringe is also known as first minima. Okay. So it's considered like that. Okay. Now here if
Yes.
you pay attention, suppose here they are meeting up. Okay. So here in the first maxima point, that is at this point, done. I'll show you here that how does it happen. It's happening basically like this. Okay. So this is first maxima. This is first minima. This is central bright fringe or central maxima. Understood? So when it is
Yes.
traveling the first slit from the first slit like this here, from the slit 1 and from the slit 2, the light is traveling this much more of the distance. Okay. This distance and this distance is almost same. We are comparing it like this: one wave, two wave, three wave. So similarly here also one wave, two wave, three wave, like that. Okay. And this much amount of the thing, this much amount of the thing is been traveled little bit longer. Correct?
Yes, ma'am.
Okay. So for first bright fringe, always remember one wave difference is there between the two waves, wave 1 and wave 2. Understood?
Yes, ma'am.
Okay. So path difference will be always 0, lambda, 2 lambda, 3 lambda, and so on for bright fringes. Clear?
Yes, ma'am.
Okay. Similarly, the path difference for dark fringe will be lambda by 2, 3 lambda by 2, and so on. Clear?
Yes, ma'am.
Okay, now let's focus upon this diagram also. That suppose here this is slit 1 and this one is slit 2. In between the two you have d distance. Okay. And the distance between the slit and the screen is capital D. Okay. Now after this, please pay attention that if suppose, that if suppose the very first fringe from slit 1 from the from the center of the two slits, that is slit S1 and S2, is got deviated by angle theta when we had taken one wave difference. This is a path difference. So this angle is suppose theta. Understood or not?
Yes, ma'am.
Okay. Similarly, this thing over here also you will see that it had traveled this much distance. So from the central bright fringe, let's say the angle is theta. How did I done that? Let's say this is the parallel line and let's say yeah, we have one more parallel line over here. So this and these sorry, this line and this line if I consider, then it will be giving you. Okay. So basically, if you see it clearly, it's nothing but if suppose this angle is theta, this angle is theta, this angle is 90. Okay, then this angle will also be 90 this angle will be 90 minus theta. Correct?
Yes, ma'am.
Okay. So similarly, what will happen here if I can calculate the angle, this angle and this angle will also be theta. Are you
Yes, ma'am.
getting?
Yes, ma'am.
Just check it clearly. This angle will also be Here also I will get theta. Here also I will get theta. Correct or not?
Yes.
Mathematically, I am saying.
Yes, ma'am.
Correct. Okay. So this angle is also theta. Connecting theta, small d, capital D, and this is nothing but small s. Small s is the distance between central bright fringe and first bright fringe. Okay. So the formula to connect these things will be given as the width between or the distance between first bright fringe and the central bright fringe is given by lambda d over small d. Very important formula. Okay. And the angle theta is given by n lambda equals to d sine theta.
Yes, ma'am.
Okay. Understood or not?
Yes, ma'am.
Sure.
Yes, ma'am.
Okay. So this is n lambda equals to d sine theta, where n are the whole numbers or the number of fringes. Okay. Now similarly, this is for bright fringe. First maxima 0 lambda. Okay. This is the path difference. Now let's calculate the phase difference also. So phase difference for the bright fringe is nothing but 0, pi, 2 pi, and so on. And the phase difference for dark fringe will be pi by 2, 3 pi by 2, 5 pi by 2, and so on. Clear?
Yes, ma'am.
Okay, done. Now after this, we have effect of diffraction. Okay. Now let's see the effect of diffraction, how it can be studied. So basically what happens is light is diffracted when it passes through the slit, correct? And that means every slit which diffracts some of the pattern on the screen. Okay. So it causes the fringes to get formed on the screen, and also you will see that they vary in the brightness as they move from central fringe to extreme ends, like here. This will be having highest intensity, this will be little bit low, and then after this gradually it will decrease, correct?
Yes, ma'am.
Okay, so how the diffraction pattern is happening, that we have to check over here. Okay, so let me show you this, how does it happen. Check this picture. So what is happening over here is, this is central maxima, then this is dark fringe, then this is first central fringe, sorry, first bright fringe, this is first bright fringe of the left hand side. When you have two slit pattern, when you have three slit pattern, then you will get this type of fringe, means you will see one wave. Okay.
Yes, ma'am.
Inside that you will see the interference of the fringes. So something like this pattern is formed. Suppose here also again, give me a,
And ma'am?
Yeah, hello Akshita, am I audible?
Yes, ma'am.
Okay, so this is all about when you have the diffraction pattern. Did you understood these patterns?
Yes, ma'am.
Are you sure?
Yes, ma'am.
Okay, please now pay attention at the next topic, and that is multiple. Ji bhaiya, thank you. It's okay. Thank you, ji bhaiya. Multiple slit diffraction. Okay, so let's pay attention on multiple slit diffraction. What happens is in multiple slit diffraction, the intensity of the double slit interference pattern is very low. Okay, but it can be increased using more than two slits. Understood? That's why we use multiple slit patterns. Okay, now the diffraction grating is a series of very fine parallel slits mounted on a glass plate. Let me show you that thing also now to you. That what is grating thing. Okay,
Yes, ma'am.
check. So here, check this one. This is diffraction grating. You can see and observe here many thin fine lines are been given over the screen. This is the screen. Okay, and here many thin fine lines are been given. Done?
Yes, ma'am.
Okay. Yeah.
Yes.
So what happens over here is the diffraction grating is what? It is a series of very thin fine parallel slits. Okay. So these are the slits. These are not lines actually. Understood? Okay. And they are mounted over a glass plate. Like you must have seen the CD. Have you seen the CD screen?
Ma'am.
On
So,
that, many concentric circles you will observe, which will give you different colors.
yes, ma'am.
Okay. So that is basically also an example of this thing. What should I say? The diffraction grating. Done.
Yes, ma'am.
Okay. Now after this, please have a look over this thing also. That how does the light diffract in all direction from a multiple slit? Let me show you that part. Okay, because single slit and double slit already we had done, but see, this is multiple slit. One slit, two slit. How many slits are there? Slit 1, slit 2, slit 3, 4, and 5. So suppose 5 slits if we are having, and from here the source light is coming out. So 1, 2, 3, 4, 5, 6, 7. These many light is got diffracted in all the directions. Understood?
Yes, ma'am.
Okay, so when these many lights are getting diffracted, what happens here is they also interfere each other. Okay, and how does it interfere and how does it form the light? So I will take only one fringe right now. Okay, that is, let's say I have taken this fringe. Okay, and now I am taking out this particular fringe from all the slits. Let's see what will happen. Okay, so somewhere like this, you will get the pattern. Okay, the parallel light come together at a distant point. Understood?
Yes, ma'am.
Okay, so what kind of parallel light picture you will get if we calculate the mathematical formula for this given pattern? That will be something like this. Okay, like here we have A, B, C, D, E, 5 slits. From each parallel light is coming. Okay, at an angle theta from the horizontal. Okay, and each slit is having x distance from the other slit distance. Are you getting?
Yes, ma'am.
G. Okay, so यहाँ पर let's pay attention. This is A and this one is B. Okay, now right now I'm showing you just for this slit A and B. Let's compare the two. So here you are having theta angle. Here again you are having a theta angle. And n lambda times this wave has traveled more distance. So the path difference is n lambda. Distance between the two slits is small d. Understood?
Yes, ma'am.
Okay. Any doubts that you are facing in this?
No, ma'am.
Good. So they will ask you that how you will consider all these things. So very simple. You will give n lambda equals to d sine theta. The formula remains the same. And if you need to find the angle, the sine theta will be equals to n lambda over d. This will be your formula to find out the theta angle. Okay.
Yes, ma'am.
Yeah. So you have to write here n is the number of fringes which has been traveled. Done?
Yes, ma'am.
Okay. Now after this, let's do one question. I'll give you one question and I'll solve that. Check here. Okay, suppose this is the question. If blue light of wavelength 450 nanometer and red light of wavelength 700 nanometer are viewed. Okay, so let's take one particular slit. From here, I am just contributing the two lines, red and blue. Done. And then these red and blue line, obviously red light will be above and blue will be down. And similarly here also blue and red. Okay, so here this will be your central bright fringe. Done. What it is given? That 450 nanometer is for red light and 700 nanometer is okay, and they are viewed through the grating of 600 lines per millimeter. This is the grating lines it had given, number of lines. Okay, at what angle you will
Yes,
get the
ma'am.
first bright blue and red line. Okay,
Yes, ma'am.
this is what the question says. Now, if I say that formula is n lambda equals to d sine theta, then how to find the d? D is basically how much it is? Distance. Obviously, small d is what? The distance, right? Between the two fringe. Correct or not?
Yes, ma'am.
Okay. So, 600 lines per mm is given. So, in 1 centimeter, they had, sorry, in 1 mm, they had 600 lines. Correct?
Yes, ma'am.
Okay. So, how much will be the distance? 0.00167 mm. Correct?
Yes, ma'am.
Okay. How many number of fringes are there? So, we have to find for first bright fringe. So, n will be 1. Correct?
Yes, ma'am.
Let's solve for sine theta over here. So, sine theta will be 450. I'm solving it right now for 450 wavelength. That is blue light. Okay. So this
Yes,
will
ma'am.
be 450 into 10 raised to minus 9 because it was given nanometers. Done. After
Yes,
this, I will be having this value and lambda equals to d sine theta. That is the question. Okay. So sine theta equals to n lambda over d. Correct.
yes, ma'am.
So this is lambda, n is 1, multiply it with 1. What is small d? Small d is 0.00167. Okay. Now after this, we will be having what? Sine theta value. So when you solve this thorough thing, please solve it in your calculator somewhere. You will get 24.8 degree. So first I had sorted it for you. Okay. Other things you can solve at your own. Do you want to solve it?
Yes, ma'am.
Please do it. Kindly be quick. So this is blue color. No, blue color will be inside. No, my bad. This is blue and it will be 700. Here the angle is 24.8 degree.
Uh, 2.6 into 10 to the power minus 4, ma'am.
Sorry,
Uh, why am I getting one? Ma'am?
your,
Oh,
जी
okay.
भैया जी.
To take the sign inverse.
Your voice is quite low, Akshita, sometimes.
Okay, ma'am.
Yeah, it's okay. You do your answer question. सबसे कौन बताया कि वहाँ पे उसका लाइफ चला गया है. चल रहा है.
Ma'am,
था अपना अंधेरा में काम कर रहे हैं 43 पे इसका नहीं कर नहीं तो हम आपका लाइट एक एक करके काट देते हैं नीचे वाला एकदम पूरा काट देते आप काम कर रहे थे इसलिए हम एक एक करके काम
Are you done, Akshita?
yes, I did the same thing, but I don't know why I'm getting the angle as 0.015. I took the invert after that. Here I took
हाँ तभी बोला मैंने. Yes. Say, Akshita.
I entered the same thing here, ma'am. But when I took the sine inverse, I it as 0.015.
0.015, no? So it's correct.
Yes.
If it is coming 0.015, your answer is actually 15 degree, no? 15.6 degree somewhere. 0.0. पहले कैपेसिटी चेक कर लें. इसी टाइम शाम को मैं अवेलेबल होगा. ठीक है.
ऐसे कितना बजे से
4 बजे. हाँ. Okay. So is it done?
Yes, ma'am.
Okay. Fine. Akshita?
Yes, ma'am.
Okay. Now after this chapter is over. Please do one question for me. Okay. This question, this chapter got over. I'm starting with C4. Done?
Yes, ma'am.
Check. This is the question.
0.01 millimeter apart. Parallel laser of a screen.
Are you done?
No, no, 1 second.
Akshita, you need to be quick, beta.
Yes, ma'am. Yes, ma'am.
Yeah. Okay. So you were saying you are getting answer 0.015, right?
Yes, ma'am.
Mm-hmm. 1 second. I'm giving you why you are getting this.
Can you scroll down for the question, ma'am?
Yeah, sure. Check it. So basically it's 450.
And I just like but the form in the formula we have like only 1D, but here we have 2Ds.
Okay, so two narrow slits, these are this much apart, that is small d. Eliminated wavelength is this. Fringe spacing we have to calculate, that is y. On a screen, which is having capital D, that is this. So I had given you the formula over here, and that is S equals to lambda D over D, correct?
Yes, and that has 2Ds.
Yeah, S equals to lambda D over D. Done. So lambda is given, capital D is given, small d is also given. You have to calculate S. Calculate the fringe spacing Y. Where
Yes.
is that given? Here the fringe spacing is S. So you have to calculate S. Done?
Yes, ma'am.
So S you have to calculate. Yeah, go ahead. Yeah, what you were asking after that?
No, I was only asking that.
Acha. Okay.
And I'm getting 9 into 10 to the power minus 5 for the first one.
Okay. Do the next one. Kindly be quick.
6 into 10 to the power minus 5 for the second one.
Okay. Do the next one.
Is there a third question?
Oh, this is it.
Okay. The last
You
one,
had
the 6 into 10 to the power minus 5.
minus 5.
Yes, ma'am.
Okay. Done. So let's do the next part now. Okay. And that is your C4 part. C4 is standing waves and resonance. Okay. So standing waves and resonance is the part. Okay. Now listen here very, very carefully. What are the standing waves basically? So the standing waves are nothing but when you have two terminals that are the fixed ends. Suppose here I am having a fixed end. Okay. and here I send a pulse, and then it is incidented on the second end, and hence it will come back as a reflection of it. Done. Now, when both the incidents and the reflection are been done at the same time, you will get the first harmonic to be formed over here. Okay. So the incident wave and the reflected wave both are coming at the same time. So this particular thing which is happening, and this pattern which is created is known as first harmonic or fundamental mode. Done. Now here, if you pay attention, it is a pulse. So one pulse is having a distance of lambda by 2. Correct?
Yes, ma'am.
Okay. So the length is lambda by 2. When I calculate lambda, it will be 2L. Correct?
Yes, ma'am.
Okay. Now need to pay attention whenever you have a closed thing, whenever you have a closed, and you will get the term which is known as node. Node means where your amplitude is equal to 0. Done.
Yes, ma'am.
Also, there is a point where your amplitude is maximum, which is known as antinode.
Yes, ma'am.
Here, your amplitude will be maximum. Correct?
Yes, ma'am.
Okay. So when you have open end, you will get node. When you have closed end, you will get node. When you have open end, you will get antinode. Correct?
Yes, ma'am.
Okay. Now after this particular thing says us that the wave is not progressive in nature. It is standing at one place and it's just vibrating. Okay. So hence a standing wave is never progressive in nature. Second thing, it is always released from a coherent source. Third thing, it never transfers the energy. Okay.
Yes, ma'am.
It is a coherent source. Fourth is they both should come from opposite sides. What both? The incident and your reflected wave, right? This is incident wave, this is reflected wave. So if you have a progressive wave, it is like this. So it is continuously traveling in nature, continuously traveling. But for a pulse, it is just this much. Okay, so this much is lambda by 2 and this much is lambda, correct?
Yes, ma'am.
The same wave have got reflected back. This is the reflection. This is not the wave. Correct?
Yes, ma'am.
Okay. So let's calculate over here. As I had told you, here the length is lambda over 2. So lambda will be length 2L. Okay. We have the formula V equals to F lambda. Correct?
Yes, ma'am.
Okay. So here my F will be V over lambda or C over lambda. If you have light wave, if you have sound wave, it will be V over lambda. Correct?
Yes, ma'am.
Okay. So lambda is 2L. So my first harmonic will be C over 2L. Correct or not?
Yes, ma'am.
Lambda is having the value 2L. So I have placed the value over here. 2L.
Yes, ma'am.
Any doubts?
No, ma'am.
In your syllabus, it has been involved in two type of things. One is open pipe. Let's do the study of that. So open pipe means when both the ends are open. So very first basic harmonic, I guess you will going to get this much. Open and stands for antinode. This is your node. Again, this is your antinode. Understood?
Yes, ma'am.
So this will be your first harmonic in your open pipe. Any doubts?
No, ma'am.
Okay. So between one antinode and node, you will have lambda by 4 length. This is also lambda by 4 length. How did I done that? This is my wave. This is 0. This is lambda by 4. So from one node to one antinode, it is lambda by 4. Then it is lambda by 2. Here it is 3 lambda by 4. Here it will be 1 lambda.
Yes, ma'am.
Making sense, Akshita?
Yes, ma'am.
Are you sure?
Yes, ma'am.
Okay. So the total length I had obtained over here will be lambda by 2. Correct?
Yes, ma'am.
So lambda here will be 2L. So what will be your first harmonic? So my first
L.
harmonic will be V equals to F lambda. Hence, it will be F1 equals to, F1 is the first harmonic, okay? V over lambda or V over 2L. Clear?
Yes, ma'am.
Similarly, you can find it for second harmonic. Let me show you what is second harmonic now. This is my pipe. So you should get two harmonics over here. So one will be like this, one will be like this, and one will be like this. One this and another like this. Okay?
Yes, ma'am.
This is second one. See, this is the correct, the secondary. Correct?
Yes, ma'am.
Any doubts?
No, ma'am.
Okay. So let's calculate the length over here. This one is lambda by 2 and these two are lambda by 2. Correct?
Yes, ma'am.
Okay. So that means I will put here lambda by 2 equals to this much is lambda by 2. This much is lambda by 4. This much is lambda by 4. So total length is lambda. So what will be my second harmonic? V equals to F lambda. So my second harmonic will be equals to V over lambda. Nothing but, yeah, V over lambda. V over L. Correct?
Yes,
Check
ma'am.
over here. V over 2L and the second will be V over L. Isn't it?
Yes, ma'am.
Any doubts?
No, ma'am.
Okay. So this one is the thing. Now let me show you this thing over here also. So this is the standing wave harmonic for the open pipe. Clear?
Yes, ma'am.
Any doubts?
No, ma'am.
Are you sure?
Yes, ma'am.
Okay. So this will be lambda equals to 2L. The exact thing I had taught. Lambda equals to L for the second harmonic. I had taught third harmonic 2 by 3L. Done. So this you have to solve whenever it is coming in the exam. Done. Now let's do study for the open closed pipe also. Now what is a closed pipe? Let's have a look at that also. Suppose here I am filling a water. Here I am placing my pipe. So I think it got closed from this end. If I put a tuning fork over this and I vibrate, it will be formed like this. Correct? So that means for closed pipe, the basic harmonic will be this. Correct? So this
Yes,
is
ma'am.
node, this is one antinode. So one node to one antinode, the length is lambda by 4. Correct?
Yes, ma'am.
Lambda will be 4L. So V equals to F lambda. When I apply this, my first harmonic will be V over lambda or V over 4L. Isn't it?
Yes, ma'am.
Okay, let's go for the second harmonic. This is my pipe now. So this is created like this. This is created like this. Okay. So that means this will be your lambda by 2. This is lambda by 4. Correct? Correct?
Yes, ma'am.
So what will be the length over here? Tell me.
Lambda by 2 plus
3 lambda by 4.
Yes, ma'am.
Okay.
Yes,
So that means my lambda will be 4L over 3.
yes, ma'am.
Check wherever you are facing doubt, you can stop me in between.
No, ma'am. No, ma'am.
Correct, no? So V equals to F lambda. So my second harmonic will be V over lambda. Nothing but 3, not 3, but it will be 4. Yeah, I was correct. 3V over 4L. Check. Is it correct?
Yes, ma'am.
Okay. So I think this will be if I choose for this, it was V over 4L, and here it is V over 4L 3 times. So my F1 is 3 times of F2, correct?
Yes, ma'am.
Okay. So this is how you have to just do it. Okay. And similarly, you will find for other things also. Okay. So I'm showing you now the wave patterns for closed pipe.
Yes, ma'am.
Check. Is it correct?
Yes, ma'am.
You want to ask anything? So here, how many harmonics are formed? Very basic is first harmonic, then third harmonic, then fifth harmonic. So it is running the harmonics in the odd system for closed pipe. Whereas if we are choosing open pipe, it will be running in the whole number. First harmonic, second harmonic, third harmonic, fourth harmonic, like that. Okay?
Yes, ma'am.
Any doubts?
No, ma'am.
And if both the ends are closed, then you will get let me write it first. Otherwise, one close end pipe. If both the ends are closed, you will get this. So here you will again have first harmonic, second harmonic, third harmonic, and like that. Okay. You just have to remember you can make the patterns at your own also. You just have to remember that at the closed end you will have note, at the open end you will have anti-note. Okay. Then you can do it at your own.
Yes, ma'am.
And you should be aware that how much is the distance. So between one node and anti-node, it is always lambda by 4. And between one node to node, it will be lambda by 2. Similarly, from anti-node to anti-node, it will be lambda by 2. Understood or not?
Yes, ma'am.
Any doubts?
Ma'am.
Akshita?
Different possibilities are anti-node to node, and then node to anti-node, and then node.
No, bache.
And then
Possibility is always, you will get the distance from node to anti-node, which will be always lambda by 4. You will always get the possibility of anti-node to anti-node, which is again lambda by 2. Again, you will get node to node. This will be lambda by 2. This is completely open. This is completely closed. This is one closed, one open. This is the probability are 3 only, no?
okay,
For
ma'am.
2 faces, right?
Yes, ma'am.
Okay. Any other doubts?
No, ma'am.
Sure.
Yes, ma'am.
Okay. So now after this, we are having standing waves is done. Okay. Anything you want to ask out of this?
No, can you just draw the diagram
Sure. You want to draw it?
yes, ma'am.
Okay. Let me give you the time for this. But you need to go a little quick. Okay.
Okay, ma'am.
Yeah. Here are your diagrams. This is for standing wave on open pipe. Yes. Go ahead. You want to write formula also? This is also given. Okay.
Yes. Yes.
Are you done, Akshita? You need to be a little quick, beta.
1 second. I just like lost internet connection, so I'm just doing the last.
Sorry? What you
My
are saying?
network connection just went by my network connection went and I rejoined. I couldn't
Acha,
copy the
okay.
last part, so I'm doing.
Acha, okay.
Yes, ma'am.
This is when one end closed. Okay.
Yes, ma'am. Ma'am? Hello, ma'am?
Yeah, say.
Yes, ma'am. We can move the next slide.
Are you done with all?
Yes, ma'am. 1 second. I'm doing this part.
So basically what happens here, Akshita, is all the wind instruments that we are having, no, like flute, your clarinet, then your trumpets, then your church organs, they all are using standing wave patterns. Done?
Yes, ma'am.
And what is the main difference between these different instruments is that the way that the air is made to vibrate inside it. Okay? Like I can give you an example. Suppose I'm having clarinet with me. So it is a thin piece of wood only. Okay. And it is made to vibrate the particular air done inside it when the lips actually vibrate.
Yes, ma'am.
Okay. Whereas if I compare it with a flute, then flute is the instrument in which the air is vibrating when we blow over the sharp edges of those. Okay.
Yes.
Okay. So it is something like that. And what happens is we can also blow the higher notes also. Okay. And how it will be done? By blowing very harder. Done. What happens is basically it causes the higher harmonics to sound louder. Okay. If we have higher harmonics, the louder sound you will get. If you have lower harmonics, you will get whispering sounds. Okay. So this is basically
Yes, ma'am.
increasing the frequency only, no? So frequency means high pitch.
Yes, ma'am.
Okay. So basically what happens if you ever have heard the playing the recorder, then you must have had the problems like that. If you blow too hard, a very high pitch noise does not sound so good in your speakers, right?
Yes, ma'am.
Yeah. So basically a high pitch voice has been sound like that only with the number of high frequencies. Done. Now we are remaining with only a very small topic of this chapter, and that is damped wave. Okay. So that we will do it in the next class.
Yes.
Done, Akshita?
Okay, ma'am.
Okay. Yeah. So let's continue tomorrow. Bye.